Good morning. I am Mrs. Supraja Hire, Assistant Professor, PICT, Pune. So today I am discussing the distributed systems course from the SPPU syllabus. We are already had the introduction about distributed system, and today we are talking about the middleware. In this particular session of the middleware, we are going to discuss about significance of the middleware into the distributed system, its role, actually some introduction or just name for the distributed system, and what is exactly meant by the middleware and how it functions. While creating this e-content, I have used or borrowed some free uh, figures or the sketches from the and some music pieces from the freestockmusic.com and Creative Commons org, and also from pixels.com. I like to thank you them and acknowledge their efforts in creating such a good content so that we can use it to explain the things in a better way. Thank you. In this presentation will help you. We have explained what is meant by middleware. This is the introduction to the middleware. Obviously, we know that the distributed systems is the autonomous computers are present with the separate memory space and with the separate CPUs. Okay, so these are the multiprocessor systems, and those are distributed geographically all over. So obviously, there should be a coordination between the nodes, and basically this is done with one of the component, and that is the role of middleware. So we are going to discuss in detail the role of middleware, then obviously the architecture where it is present uh, in case of distributed systems. It is at the client side, it is at the server side, it is at the application side, or it is at the server side. All these things we are going to discuss into the architecture of the distributed system, and middleware system itself or middleware component itself is coming up with its own architecture to have the middleware services. So that will be introduced in this particular presentation. Obviously, types of the middlewares and the examples and the middleware tasks. Let us see what is middleware. Is it a software or it is a hardware? We can say that middleware is a software. It's a software components that enables the communication and obviously the various services management. It can be the management of the data, it can be the management of the network infrastructure, it can be the management of the control signals or anything such type of the things in form of service, and that management in case of distributed applications, in case of the networks, okay, uh, and that software component you can say it as a middleware. So those are coming with the service-based architectures. The middleware components or middleware softwares are coming with the service-based architecture. These services, as I have explained, can be of any type. It can include the enterprise application integration. The application itself can get integrated. It included data integration. Just the message, that is the control messages, can be passed. Then context awareness is included. Then objects. can be passed from one computer to the other geographically placed computer. It can be having the enterprise service bus itself shared between the different computers. Middleware software will make it easier for the developers to implement a communication for the input output, for sending the control signals, for sending the data. So all type of the sharing, the coordination and the cooperation for the applications is possible with the help of middleware. Now, what is the role of middleware in distributed system? Obviously, as I have told you, distributed systems are complex systems because independent autonomous physical nodes are there, and those are loosely coupled nodes, and those are connected to each other to share the things to run a single application. That is what exactly you can say is the distributed system. So you have to manage the complete autonomous computer system and communicating with each other overall to run a single application, and this make this system very complex. Any distributed application is made complex. The activities involved can be the supplier, customers, partners. Those are at the end user side or at the application side. Those are sharing the various information, and that is stored, managed on the different computers. So one way of achieving this is using the cooperating and communicating, synchronizing the communication, that software components, which which we know that it is a middleware. So there are the number of middleware solutions are available, which makes this possible. So there are the array of choices available for the enterprise. For what purpose? In between what? In between the control signals, in between the data passing, in between the message passing, in between the network signal control, in which form the communication, the coordination is necessary in their enterprise application. So this choice is the selection of the middleware, and depending upon that choice the middleware should be designed. What are the advantages of the middleware in the distributed system? So middleware is used in distributed system as we are discussing to provide the common services. So whether only the data sharing, the controlling or control signals or sharing the network or other things is only the service offered by the middleware? No. Other services like the authentication, authorization, compilation to improve the performance, what sort of the communication is required. Such type of the services while inputting the data, while transferring the data from one computer to the other computer. Obviously, when you are transferring the data over the long distance, the noise and other errors can be introduced. So that error handling mechanism, these are also easily carried out by the intelligent middleware or by normal middleware also, by introducing the small components into the middleware architecture. So these are the various advantages, not only the data sharing, but the security mechanism, the network sharing, the bandwidth sharing, the control signal passing, the while input and doing the input and output of the data, buffering of the data. So these are the small services. Those can be easily accommodated by changing the architecture of the middleware, and that make your distributed application more performance enhanced. Middleware can be modularized from the application, so it has been better potential to reuse. The reusability is the very good possible with the middleware. Because see, middleware is not a you cannot say it is a technology basically. This is the architecture we are suggesting. So it's not owned by a single company. So they can build their product as a middleware. But when we are discussing about the middleware, we are discussing about the technology, and those are freely available. So by using those freely available plugins into the with the help of these softwares, you can develop your product which can be your customized middleware. But basically, middleware, when we are talking about the architecture of the middleware, we are talking about uh, really available middleware, or when we are talking about architecture, we are talking about a technology. Application developer can design middleware so it's sufficiently high level. So they are basically design the use of technology, and it is very at the abstract level or very high level. Okay, and then we can use it and use our own component, and we can customize that middleware. So it basically becomes independent of specific hardware environments or operating system. So what can be the key challenges for developing of the middleware in the distributed system? So distributed system first of all require considering the software architecture at the both client and server side, and you know that these are the heterogeneous. At one side you are using the mobile phone, at other side you are using the desktop, at other side you are using the laptop, or you are using some embedded sensor technology. Okay, nowadays it is very possible, or you are using the artificial intelligent agent, or the software soft sensors also, which is a software component acting as a sensor, or you are using the multi-core system also where the logical processors are possible. So this is the heterogeneous environment. So you don't know at a client side, and at basically the server you are having the high-end computers, okay. But at a client side you are having the various network topologies. One side it can be a mobile, it can be a Bluetooth network, or it can be a normal LAN WAN type of the network, the fiber optic network. So you are having the different client nodes uh, with the in the different form. You are having the different logical nodes. You are having the different network topology. So this also makes the distributed system very complex. So coordination and the communication between those nodes is made very complex. Now, middleware technology helps developers by handling this heterogeneity and this complexity. So, these are very easily plugged in into the cross platform, and the network management, security enforcement is very easily possible with the help of middleware. But obviously, this forces the challenges also onto the design of the middleware. The developers of middleware technologies are focusing on these issues when they are designing the new technologies for the middleware, or they are designing the middleware architecture. Also, as the cloud and all ubiquitous computing is booming up, the scalability, okay, of the distributed system. Auto-scaling, the distributed systems are mainly auto-scaled systems. It must be an auto-scaled system. So the scalability is the important property of the distributed system, okay, which are making distributed system highly popular. And this scalability is forcing uh, challenge when you are going to design a middleware architecture. So what are the various tasks those should be carried out when you are designing the middleware? First of all, it should have an object model support. Middleware should offer mechanism to support a inter incorporated object model interoperability. Okay, the objects from the different devices should be, the object model should be standard. Then operational interaction. The mobile phone is operating with a different protocol. The network is operating, mobile network is operating with a different protocol. The laptop, and so the WAN and LAN. Okay. So this operational interaction should be seamless. Middleware should allow the operational interaction between two objects. Now, remote interaction, obviously the remote procedures, over the nations, over the large geographical area, all these distributed systems are spread. So the remote interaction should be carried out. The remote object invocation, remote procedure invocation, remote application invocation should be possible with the help of middleware. And transparency, from the standpoint of program, the interaction between objects is identical for both local and remote interactions. For both, as well as the object should be handled as if you are handling it locally when you are handling it remotely. And this mechanism is called as the distribution transparency. So, whatever the function calls you are sending, whatever the variables you are using, whatever the algorithms you are using related to the object designing, those should be same as if you are using it into the local memory with the local processor when you are accessing it to the remotely. And this you can say it as a distribution transparency. Technology independent, as I am telling you, the heterogeneity is the most important parameter that is forcing challenge onto the middleware design. So the technology is different at the client side, majorly at the client side. So technological independence should be handled with the middleware, or this is a task assigned to the middleware that it should be done carefully. Now this figure is telling you the structure of the middleware. Okay, so we are having the different applications here: application 1, application 2, application 3, and these are the servers which are offering services to these applications. Okay, so we are having application 1, application 2, and these servers, these are probably giving you the service of the some statistical calculation, some machine learning algorithm is working with this particular terminal, some security mechanism is carried out with this service, and all these application is sharing whatever the uh, type of the services those are offered. Now, how the communication should be carried out, or how it should be integrated. So this is done with this software component which is called as a middleware. So API, the application interface, will communicate to the middleware, and middleware in turn will communicate to that server. Okay? So it's the responsibility inside this component, whatever is going to happen is going to happen. The communication, coordination, and all other services which are other than the servers are offered by the middleware. So this is a structure of the middleware. Okay? And this is here, this component in the overall vertical architecture of your distributed system. This component middleware is present. This software middleware is present. Obviously, into the middleware, what sort of the technology you are using? Obviously, as I have told you, it depends upon the enterprise application can be used. How the middleware works? You are having the application programming interface API as shown into the previous figure. Then remote procedure calls, which are from the remote servers present. These are present in the form of middleware. Some message oriented services also offered by the middleware. So the messages are sent to give the remote procedure calls with the help of middleware to the different servers, and then you are getting the middlewares services. Now, what are the standard characteristics of middleware? As I have told you, it is a non-proprietary. You are talking about the technology, you are talking about the architecture. So obviously it is open source, it is a non-proprietary. You can customize the middleware. It should be freely available. Technology is independent of operating system, any proprietary products, hardware. Democratic creation process, the creation and subsequent evolution of the standard is not ruled by the dominance of one company. Okay, so you have to give very abstract architecture of the middleware, and then it will be given. The product availability standard is only effective if products exist. As I have told you, if your proprietary components are used, you have filled up the abstract points into the middleware architecture with your proprietary software, then it can be in the form of product, you can distribute that particular middleware. Now, types of the middleware, uh, you are having a database middleware, you are having an application server middleware, you are having a message oriented middleware. These are the main types of the middleware. And transaction processing monitors or the web middleware, XML based middleware, intelligent middleware. These are some types of middleware. Now what a database middleware is doing? Oracle Golden Gate, MySQL replication, DBCP. These are the example of the database middleware. So these are used to manage the resources and provide services to the applications on the top of operating system. Application servers, whatever their function, occupy a large chunk of the computing territory between the database servers and the end user. So this application server, like the Glassfish or like that, they are handling the session management, enterprise Java beans, and they are helping your database server. So between the web client and the database server, you are having a web server. So this is or the application server. When the web server is not other than handling the HTTP request, it is doing some bean handling, the security handling, the session management, this task also, then it is called as an application server. For example, Apache web server is a web server, but Tomcat is the application server. So this application server, you can call it as a middleware, because those are present between the client, web client, and then between the database server. So this is a classic example of the application server middleware. A API is a method of connecting application with one another, okay? But it is a third party tool. Okay? So you can call that API, that third party tool, and that can support the method. Okay? So this is developed by somebody else, okay? And this is freely available. You have to use it in your application. Now this is a message oriented middleware. So we are having 1, 2, 3, 4 application. Messages are sent to the servers. Messages are sent to the applications. Okay. In case of service oriented architecture, we are having basically this message oriented middleware. RPC is another type, that is you are calling onto the remotely placed server, different server, okay. You are having the procedures or some other computer, you can say that procedure, that program is running, and you have to use by taking the input at your computer. You want to access that algorithm which is in the form of procedure running onto the other computer. So this is a software, the RPC middleware is a software make this possible. Okay. So this is called as RPC middleware. And then instead of the uh, procedures, if you want to use the object, okay, in case of basically Java, you are having RMI. and you are having a object request broker, which allow you to use the object which is created into the memory of the other PC present at the other geographically present computer, and use that object into your program. So this is your ORB. Okay? So these are the different types of the middleware what we can have. You can have a web-based middleware also,